Welcome back, everybody. Last week of notes. Hallelujah, right? We've got, let's see, 3 more lessons this week. You got a quiz coming up on Thursday. Hopefully, you've already taken a peek at your final exam review. And then next week on Wednesday is your final. So we are in the home stretch, okay? So we left off our last lesson talking about simple interest, which we said was one way to either charge you a fee or interest on a loan, or earn or accrue interest on an investment. So simple interest isn't the only common form of interest that you would see. Another common form is what we call compound interest. So compound interest is another way to, let's change my color here, to either charge interest on a loan or to earn interest on an investment. And what's going on with compound interest is that you basically are earning interest on interest. Okay, the result is interest is earned on interest. And then I will try to show you how that works in this next example here. So let's say you had $1,000 invested at 2% for 1 year. The simple interest formula, we take that principal, we take that rate, we take that time, we multiply, and we have an interest of $20, interest amount of $20. So at the end of the year, you'd have 1,020 total, okay? Now, with compound interest, you have the same, just to compare apples to apples here, let's say we take that same $1,000 investment, the same interest rate of 2%, and the same time frame of a year, but instead of calculating simple interest, we're going to, let's say, compound the interest twice. What that means is you take your investment and you calculate the interest twice over the period of the year. So halfway through the year, you calculate your interest. So you take your $1,000 principal, you take your rate of 2%, and then your time is the first half of the year, and you calculate your interest at $10, right? Now that $10 interest gets added into the principal so that for the next half of the year, when you go to earn interest again, it's not just on the $1,000 that you started with. It's on the $1,000 plus the $10 of interest. So the second time around, you end up with $10.10 of interest. Then in this case, you end up with a total of $1,020.10. Now, I know that's not a lot difference, but that's because the interest rate is really low and we're only looking at a year. But if you were to, let's say, take this investment and spread it out over 15 years, and let's say instead of compounding twice a year, maybe you compounded it every single day, you're going to earn more and more interest on your interest. So compound interest, it could be beneficial. It depends on who you are, right? If you're borrowing money, you don't necessarily want compound interest because you don't want your fee to be accumulating on interest and the principal amount that you borrowed. But if you're investing money, you want to earn interest on your interest. So if you're if you're an investor, then compound interest would be to your advantage. If you're someone that's taking out a loan, if you're a borrower, then you don't want to borrow something with compound interest, okay? But the concept is you are earning interest on interest. Now, fortunately for us, we don't have to worry about, let's say we were compounding interest every single day, we don't have to worry about doing our simple interest formula every single day and then adding all those amounts up. We have a formula that calculates compound interest for us. So here's our compound interest formula. A equals P times the quantity 1 plus R over N raised to the NT power is going to give us the final amount of an investment. So the A in the formula represents the total amount that you have accumulated, that you have accumulated after a certain number, a certain amount of time. So different from the simple interest formula. The simple interest formula only calculates the interest. You would have to add it to the principal to find that total final amount. This formula actually calculates the total final amount. P is the same as it was in the other formula. It is the principal amount or the starting amount. R is still the rate, still given as a percent and converted to a decimal. T is the time. And for our compound interest formula, that time has to be in years, must be in years to go into this formula. So if we had any kind of time that wasn't in years, we'd have to convert it. And then in this formula, we have to know how often we're going to be compounding the interest. So N is the number of times per year that we will compound interest. So what you'll see in a situation is probably one of these words. It'll say, oh, interest is going to be compounded annually. Well, annually would be once per year, so n would equal 1. If it was semi-annually, that would be twice per year, so n would equal 2. If it was quarterly, quarterly would be 4 times per year, so n would equal 4. Monthly would be 12 times per year, so n would equal 12. 52 weeks in a year, so weekly would be 52. And then daily, now I know there are 365 days in a year, but we're going to use that banker's rule we talked about last time. So the banker's rule says there are 360 days in a year. So if it says daily, we're going to go with n equals 360. Okay, and I think when you're working on these problems in MATLAB, it will say use 360 days in a year. Okay, so let's try this out. So suppose you invest $4,000 at 8.25% interest compounded semi-annually. How much will you have total after 5 years? So we have the principal amount of $4,000. We have a rate of 8.25%. If we make that a decimal, we can either put 8.25 over 100, remember? So if you want 8.25 over 100, or we can make that 0.0825, either one of those would be fine. And then it says interest is compounded semi-annually. That means n is 2, twice per year. How much you're going to have total after 5 years. So t is 5 years. Okay, so how much total? How much total? That's the question, right? Right? That's what our formula is going to tell us. So our formula says our total final amount A is going to equal our principal of 4,000 times 1 plus our rate of 0.0825 over n, which is 2, and that's going to be raised to the 2 times n times t, so 2 times 5 power. And now we get to go to the calculator. So calculator says, let's see, 4,000 parentheses 1 plus 0.0825 over 2, and then we're going to raise that to the, you're going to have to put parentheses to keep both of these numbers in the exponent here, so it's 2 times 5, or if you just wanted to plug in 10, you wouldn't have to do the parentheses. So we have $5,992, and we're going to round that to 53 cents. So $5,992 and 53 cents. Okay, so that is the total final amount. That is the answer to this question. Now, just because I know you're going to see it in MATLAB, what if I asked you how much interest was earned? How would we calculate the interest? Well, if we invested $4,000 and we ended up with $5,992.53, that difference there is the interest. So if we subtracted out the 4,000, that means there is $1,992.53 in interest. So the difference between your final amount and what you started with, the starting amount, is how much interest is either earned or charged, depending on if it's an investment or a loan. Okay? And I know it didn't ask there, but you're going to see it in MATLAB. All right, let's try that again. Let's see. Suppose you invest $5,600 at 7.5% interest for 3 years. How much will interest? Wow. Let's take that word out of there. How much interest will you have earned after 3 years if interest is compounded daily? So we have a principal amount of $5,600. We have a rate of 7.5%. So we can either plug that in as 7.5 out of 100, or we can make it 0.075. It says interest is compounded daily. Compounded daily means n is, remember, banker's rule, 360. And then how much interest will you have earned after 3 years means t is 3. So to our formula, A is going to equal, let's see, $5,600 times 1 plus 0.075 over 360, and that's going to be raised to the n times t power, so 360 times 3, and now we go to the calculator. So we have 5,600, 1 plus 0.075 over 360, and then we're going to raise that to the 360 times 3 power. We have $7,012.84. $7,012.84. Okay, so that's the total final amount. Now that is not the answer in this one. It doesn't say what is the total amount you're going to have. This one actually says how much interest. So notice, let me, I can't fit it in here, but this is our question here. Yeah, I can fit this. Hang on. Hang on, guys. I have technology. Let me scooch this down. Okay, so how much interest, that was the question here, right? The total amount, we end up with this $7,012.84, but we want to subtract out the $5,600 that we started with, which tells us, let's see, if I take $7,012.84 and subtract out the $5,600 that we started with, that means there's $1,412.84 in interest. $1,412.84. 141284, okay, in interest. Okay, and that was the answer on this one. All right. There we go. All right, if we look at number 3, the next problem here, basically we're going to be using another version of the formula. Same formula, but solved for a different variable. It's because we have a different goal. Instead of maybe you have some starting amount, what are we going to end up with after 5 years if we let it sit in an account? It's like, well, what if in 5 years I know I need to have $10,000 saved up for a car for my son who's going to be, old enough to drive? Well, then I could use a version of the formula to figure out how much I have to put into the account and let sit there to get to that amount. So we call it the present value formula, and it should make sense. So our formula for compound interest to find the final amount, right? To find the final amount A, we said take the principal, multiply by 1 plus r over n to the nt power. If instead of using the formula to calculate A, if I wanted to calculate P, if I wanted the formula to be P equals, well, if I had to solve for P and it was being multiplied by this whole expression, then I would have to divide that whole expression over. So if I divided this over, right, this 1 plus r over n to the nt power, all that's going to cancel, leaving you P, and then it has A over that part. So if you look here at our formula, there it is, A over what we had on the other side of the equation before. So if it's using the formula in reverse, this is, we have a goal, use it to, the other one we use it to find the final amount. Here we use it to find the principal amount, right? Used to find the principal amount. All right, so number 3 says, how much should you invest at 12% interest compounded quarterly for 20 years to reach $25,000? So this time they're telling us that the final amount is $25,000. And let's see, interest rate is 12%. 12%, which we could make that 12 over 100, or 0.12, and interest is compounded quarterly, so quarterly is 4 times per year, and that's for 20 years, so t equals 20. How much should you invest? Right here, how much should you invest? That's the question, that's the principal. So P is going to equal the $25,000 goal divided by 1 plus r over n, so 0.12 over 4 raised to the nt power, so 4 times 20th power. And now it's calculator. So my calculator this time, I'm gonna hit the divide button first to give myself a fraction. I'm gonna type the 25,000 in the top, and then on the bottom, 1 plus 0.12 over 4, and then we're gonna raise that to the 4 times 20 power, and $2,349. $2,349, and we're gonna round that to 43 cents. Okay, so this means if we put in $2,349.43 into this investment, and it sat there with a 12% interest rate compounded quarterly for 20 years, that $2,300 investment turns into $25,000 at the end of that 20 years. I don't know if that's really a reasonable rate. It's pretty hard to find an investment with a return rate of 12%, but I mean, imagine if you just let $2,000 sit there, eventually you have quite a chunk of change. So if that's the amount that you put in and you got to $25,000, the difference is going to show you how much interest you earn there. So if we subtracted out $23,49.43 from the $25,000, let's put that in here. Oh, come on, cursor. 25,000. If I took that away, $22,650.57. That's $22,650.57 in interest, which is a lot of money in interest. Okay? Again, I don't know how reasonable it is to look for an account with that kind of a rate, but there it is. Okay, let's try it again. How much did you invest? There's our question, right? That's telling us we're looking for that principal amount. 7% interest compounded monthly for 15 years to reach a final amount of $12,000. So our principal is what we're looking for. Our final amount is $12,000. Our rate is 7%. 7% is 7 out of 100, or 0.07. And this is compounded monthly, so N is 12 for 15 years, so T is 15. And let's plug her in. So our principal investment, the amount we have to start with to get to that 12,000, is going to be 12,000 divided by 1 plus R over N, so 0.07 over 12 raised to the NT power, so 12 times 15 power. And now calculator. All right, so division button first to make a fraction, 12,000 on the top, and then 1 plus 0.07 over 12 raised to the 12 times 15 power is $4,212.08. Okay, so there it is. You started with a $4,212.08 investment and let it sit in this account that compounded interest monthly, 7% interest monthly for 15 years. You would end up with $12,000. So again, just so you can see it, if we took away the $4,212.08 to start, then you can see exactly how much interest that is. So $7,787.92 in interest is earned on that investment. Really easy to let money sit there, okay? All right, this last little piece, we're talking about something called effective annual yield or annual percentage yield. You've probably seen APY if you've ever gotten a credit card bill. Basically what APY does is it compares a simple interest rate and a compound interest rate. So just again to compare apples to apples, this formula that we're going to look at says let's just take $1 over a year and try to figure out what simple interest rate and compound interest rate would end up with the same final amount, the same annual yield, okay? So if, for example, number 5, we wanted to find the effective annual yield of an investment with a 6% interest compounded quarterly, what we're going to do when we use the formula is we're going to find what simple interest rate would end up with the same final amount as this compound interest rate, okay? So It's our compound interest formula, but again, it's just to compare apples to apples. It's a dollar investment over a year. So notice that the principal amount is $1 here, and there's no time here because multiplying by a time of 1 isn't going to change n. So APY, APY is effective annual yield. All we have to plug into this formula is our rate and our number of times we're compounding interest. All we need is R and N. So here, let's see, R is 6%, and 6% is 6 out of 100, or 0.06, and this is compounded quarterly, so N is 4. So we have a formula that says that APY is going to equal 1 times, now we don't really need that 1, but it's the formula, 1 plus R over N, 0.06 over 4, raised to the N power, so 4th power, and then we subtract 1. And that's just to make our number a percent. You'll see that in a second. So if we plug this into our calculator, let's see, we have, get rid of all this, 1 times 1 plus 0.06 divided by 4, raised to the 4th power, and then we take away 1, and that is, an APY is approximately 0.061. It doesn't really ask where to round. If you wanted to go a little further, we could. This is about 6.14%. Now in the little word bubble there I put 6.1, but here's what this is saying. Okay, if you took $1 and you invested it for a year into 2 accounts, one that compounded interest quarterly at 6%, and one that just had simple interest at 6%, at 6.14%, you would have the same final amount. So an investment into an account that compounded quarterly 6%, a $1 investment into that account for 1 year would give you the same final amount as $1 into a simple interest account at this 6.14% for 1 year. So the same dollar, the same year. If you went into compound interest, compounded quarterly for 6%, or a simple interest at 6.14%, you end up with the same final amount. I don't know if I made that worse in my explanation, but let me just read the bubble. So 6% compounded quarterly for 1 year would yield the same final amount as 6.1 simple interest for 1 year. Okay, so that's just 2 different accounts that would give you the same final amount. All right, so you could be asked the question a little differently. Notice number 6, instead of determine effective annual yield, it says determine the annual percentage yield. Well, those are the same thing. And this time it says for $1 for a year. That's part of the formula already. So it's the same 2 pieces that we need. We need the rate, which in this case is 8%. And 8% is, what the heck? Sorry, I can't write. Is 8 over 100, or 0.08. And this is compounded daily. So we're going to say N is 360. So in this case, our APY is 1 times 1 plus 0.08 over 360 raised to the 360, and then minus 1. So APY is going to be about, let's change, just alter this here. This is 8 this time, and this is 360, and this is 360. All right, so about 0.0833, 0.833. So that is about 8.33%. Okay, so what this means is 8% compounded daily for a year would be giving you the same final amount as 8.33% simple interest for a year. So 8% compounded daily would give the same final amount as 8.33% simple interest. Okay? And if that concept is confusing, don't freak out about it. Just